Hello everyone, welcome back in the series of lectures on vector integration. This is part 5. In this lecture, I will discuss the concept of Gauss divergence theorem along with problem based on it. So let us start. Gauss divergence theorem. It says that if f is a vector function having first order continuous partial derivatives in a region B bounded by a closed surface S. Then according to this theorem, the surface integral of f is equal to triple integral of divergence of f into dv. It means what? It is also known that the surface integral is equals to volume integral. So in another word, we can say that the surface integral of the vector f is equals to the volume integral of divergence f. This is we are having the Gauss divergence theorem, where as you already know what is n cap we are having on the left side. It is known as the unit normal vector on the given surface drawn outward, and divergence we already done discussion in the previous lectures that what is the divergence. One most important thing is here that it gives a relation between what? It gives a relation between this is what? Surface integral, this is what? Volume integral. So the Gauss divergence theorem gives a relationship between surface integral and volume integral. Many times it asks in an MCQ question that Gauss divergence theorem gives the relation between what? So the solution or the answer for the same is what? It gives the relationship between surface integral and volume integral. Means how we are going to attempt the problem. The question is asking this term, and simply we will calculate the divergence of the given vector f, put it here, do the simplification and get the solution for the given integral with the help of Gauss divergence theorem. Let us see some problem based on it. Find the integral as curl f dot n cap ds by using Gauss divergence theorem. This is what we are having problem, that find the integral this much by using Gauss divergence theorem. They not given the surface name, also they didn't give us what is vector f, but we are supposed to find this one. So if you remember that in Gauss divergence theorem, in place of curl f we are having only f here, getting, and we need to find curl f here. So wherever we are having vector f in the theorem, we will replace that by curl of f. Let us see the solution. So according to Gauss theorem, f dot n cap ds is equals to volume integral of divergence f into dv. Hence, the given integral, that is double integral as curl f dot n cap ds is equals to double integral divergence of curl f into dv. If you see that in place of f I am having curl of f, so I just replace here what? F by curl of f. Divergence of curl f this much. Now if you remember, what should we do the next? If you remember, we are having a result that divergence of a curl for a vector quantity is always 0. It means the integral value will be 0. Why 0? Because we are having the result that divergence of curl f is equal to 0. We need to remember this result directly, that divergence of curl of a vector will always leading to be 0. Now without calculating anything, just only using this property, we can say the value of the given integral, that is this much, is what? 0. Hope you understand. Move to the next problem. Find the surface integral f cap f dot n cap ds by using Gauss divergence theorem, where S is the surface of the sphere this much and f is this vector. We need to find this integral by using divergence theorem, where S is given as the surface of a sphere and f is given as the vector. So if you remember, in order to calculate this one by using divergence theorem, what is this term is equal to what? It is equals to integral f dot n cap ds volume integral divergence f into dv. It means I need to calculate the value of divergence of f. So let us start to calculate divergence f for this given vector. So divergence of, as we know, that del dot f, where del is I del over del x plus j del over del y k del over del z dot the given vector. Now let us do the dot product of these two terms, and dot product, as we know, I to I means it will be what? It will comes like this term into this term into this one, and this one into this one. I into I is 1. So del over del x of 3x, it means what? I will get del over del x of 3x plus del over del y of 4y plus del over del z of 5z. Now derivative of 3x with respect to x is how much? Only 3. 4y for y is only 4 and 5z for z is only 5. The sum is 5, 4, 9 plus 3, 12. So the divergence for the given vector function is 12. Now we need to put this value in this inequality or in the divergence theorem. Hence, this will be what? 12 times this one. And now we can see, just I put the value of divergence here, so it will be 12 into dv. 12 is constant, so it can be taken outside. And now what the rest of the thing we are having? Triple integral of dv. And what is the value of dv we are having? Dx, dy, dz, which is the volume of the given surface. As we are having area as what? Double integral dx, dy. In the same manner, the volume is given by triple integral dx, dy, dz. Volume of the given surface. And what we are having given surface? The given surface is a sphere. And what is the volume of a sphere, if you remember? It is what? 4 upon 3 into pi r cube. This is the volume we are having. What is r here? R is 1. So finally, the solution will become as 12 into 4 by 3 pi into 1 to the power 3. Simplify whatever you are getting, that is the answer for the problem. This is how we will solve a problem by using Gauss divergence theorem. Simply when you are attempting MCQ on this pattern, no need to do descriptive calculation. Directly find divergence manually without writing in your notebook and put it in the divergence theorem. You will get the solution for it. Move to the next question. Find the integral f dot n cap ds, where S is the surface of the sphere whose center is this much and radius is this much. F is given as this vector. Now if you remember, same as the previous question, this will be equal to what? This will be equal to what? Triple integral, yes, over V into divergence of F into dV. This is we are having Gauss divergence theorem. So simply we need to find divergence of this one and try to simplify. To check your concept, just pause the video and try to find the solution of this question by yourself and then match the answer. Hope you have done. Let us see how I am going to do this question. So according to Gauss theorem, the integral this one equal to this much. Now put the divergence here, or simply see how we are going to calculate the divergence. So in the same manner as we have done in the previous one, del dot f, do the dot product inside, simplify, and you can see I am getting the divergence for the given problem as what? 3. So put this 3 here, so it will once again becomes what? Volume. So this will once again become volume of what? Volume of the given surface. And here, what is the surface we are having? A sphere whose center is these 3 points and radius is 3. As we are having the concept that the volume of a sphere is unaffected by its center. It totally depends on its radius. So this point is just given to you for to make you confused. So no need to pay attention for it. Directly we are getting volume from this radius. So solution will be 3 times 4 by 3 pi r cube. What is r here? 3 power 3. Now there is one correction in it. It should be what? It is wrongly written as 12. It will be what? We are having 3 into this one. So this 3 is cancelled by this one. So finally what I am getting? 3 power 3 into 4 pi, and 3 power 3 will be 3, 3, 9, 27 into 4 into pi. Whatever comes, that is the answer for the given problem. So this is how I have done the solution for this question via divergence theorem. Let us move to another question. Once again, the question is saying the integral find the integral this much by using the divergence theorem, where S is the surface bounded by these curves and the vector is given as this one. Now if you see, this is what, if I am talking about these line x0, y0, z0, x1, y1, z1, it is a cube shape. It is what? It is, we are having a cube, and it is used to identify the surface. Let us see the solution for it. So once again pause the video, try to solve by yourself. Hope you have done. Let us see the solution. According to the divergence theorem, we are having double integral f dot n cap ds equals to that volume of divergence ftv. Move to find the divergence for the given problem. As divergence we are having del dot f, and del we are having I into del over del x plus j into del over del y plus k into del over del z into the given vector function, which is 4xz into I minus y square into j plus yz into k. Simply do the dot product I to I, j to j and k to k. So this is what we are getting, the divergence, which is 4z minus y. Now put this divergence here in the statement of divergence theorem. So now we can see this is equals to triple integral v 4z minus y into dx dy dz, because dv we are having what? Dx dy dz. Now we can see it is not the formula of volume, because we are having some variable inside the integral. So we need to find what the limits and do the integration, then we will get the answer. Now you can see here directly without drawing the reason, we are having the limits. Another way is what? Draw the surface, find the limit. But here there is no need to draw the surface. Simply you can find the limit from the given curve. Now let us see what the limits we are having. Limits of x is what? 0 to 1. Limits of y is also 0 to 1, and limits of z is also 0 to 1. So put the limits here. So we will get x as 0 to 1, then y is 0 to 1, and also we are having z from 0 to 1. Inside 4z minus y into dx dy dz. Here you can see one thing, that all the three limits are constant, so order of integration doesn't matter. So I just simplify, put the limits, and I will get the solution of the problem as 3 upon 2. Let me correct the solution of the problem. What I am getting, the solution of the given problem as 3 upon 2. So now we have dealt two types of question. One type in which the integral directly becomes the formula of area of the given surface. The second is what? In which it is not the formula of volume, it becomes the formula of volume. Now some question it is not the formula of volume we are having, so in that case we need to find the limits from the given reason. Let us see one more problem. Evaluate the surface integral f dot n cap ds, where S is the surface of the tetrahedron x equal to 0, y equal to 0, z equal to 0, and z, the surface x plus y plus z equal to 2, and vector is given as this one. Now try to imagine the shape of the given surface. These are the three curves. If you remember, it is equation of a plane x plus y plus z equal to 2. And since x is 0, y is 0, z equal to 0, it means we have to take only the part of this plane which lies in the first octant. So in order to draw this one, what? If I'm putting x equal to 0, y equal to 0, what I'm getting? 0, 0, 2. This is the first point. Second point, if I am putting yz 0, so 2, 0, 2. The second point, on the basis of third point, if I am putting x and z 0, so 0, 2, 0. As we know, in order to draw a line, we needed 2 points. In the same manner, in order to draw a surface, we have to find a set of 3 points. So if this is what we are having x-axis, this is what we are having y-axis, this is what we are having z-axis. So 2, 0, 0 comes on x-axis, 0, 0, 2 on z-axis, and 2, 0, 2 in y-axis. So match these 3 points, I will get the given surface. This is the given surface we are having. Its name we are having what? X plus y plus z is equals to how much? 2. Then, so this surface will use to find the limits of the problem. But before that, let us see what is the divergence we are having. According to Gauss theorem, this will be equal to that one, and divergence we will find for the given problem in the same manner as we have done in the earlier questions. So finally, I will get the divergence of the given problem as what? It will be 2x plus 2y plus 2z. Put it in the given statement. So double integral f dot n cap ds, the given problem equal to triple integral v 2x plus 2y plus 2z into dv is what? Dx plus dy plus dz. Put all these values. Now you can see here, this is not the formula of volume. So we need to find the limits. As in the terms of limit, if I am talking from the given curve, we can see all the three variable is having base limit as 0. Now how to find the rest of the variable? If I am putting z equal, the limits of z, it is started from 0, terminated from here. The value of z here is what? 2 minus x minus y. So the upper limit is z is what? Z equal to 2 minus x minus y. We can see the same from this surface also. If I am taking a strip which is parallel to z-axis. Z-axis, if it is z, let it be, and let it be this is y. So limit of z will be what? Started here, this is 0, and terminated here, the value of z is evaluated here. So limits of z is 0 to this much, limit of y. Now eliminate z from here, so y will be what? Y is equals to how much? 2 minus x. So finally limits of y is what? Y equal to 0 to y equal to 2 minus x, and y is done. Cross this one also. Finally x is 0 to x equal to 2 we are having. So we need to put these limit x equal to 0 to 2, y equal to 0 to 2 minus x, and z equal to 0 to 2 minus x minus y into 2x plus 2y plus 2z into dx dy dz. Simplify, and order of the integration is what? If you see here, the order of the integration is what? Firstly we will do for z, then y, then x. With respect to z, the integration will be 2xz plus 2yz plus z square by 2. Put the limit these things. Whatever you are getting, then do for y. At last do for x. Simplify, you will get the answer for it. I just leave this as an exercise. So try to calculate and put the answer. So these are the 5 questions that we have done based on the Gauss divergence theorem. I am also having some practice problems for you. So the first one is evaluate the surface integral double integral S f dot n cap ds, where S is given as the surface bounded by x square plus y square equal to 1 and z equal to 0 to z equal to 3, where f is given as this vector x square plus y square plus z square into 4xi minus 2y square j plus z square into k. Do the same problem in the same manner as we have done the problem in the earlier sections. This is we are having f, so find its divergence firstly. I just give you the idea about this surface so that you can find the limits if they are needed at last. Suppose that this is we are having x axis, this is we are having y axis, and let this is we are having z axis. So we are having circle in xy plane. So there is a circle which lies in xy plane. Remember, this circle is not look like this, it is look like this in xy plane. And now I need to revolve this circle from z equal to 0 to z equal to 3. 0 to z equal to 3. So z equal to 3, suppose that this much. So if I revolve this circle from 0 to 3, so I get this shape. So this is the surface for the given problem, means a cylinder. Z equal to 0, and this is what we are having, z equal to 3. It will use to find the limits. But before that, you need to find divergence, put it in the problem, and then get the solution. Limit will be what? If I am talking limit started here, so z equal to what? 0 to z equal to 3. For limit of xy, I just take the part which lies in xy plane only. So I just take the part which lies in xy plane only. So what I will get? I will get a circle. This and this, we are having a circle. Here take a strip and then find the limits of x and y also. At last you will get the answer for the same. Second question, find the value of the surface integral double integral f dot n cap ds, where f is a solenoidal vector function. This is what, and s be an arbitrary surface. Now we need to find this integral. F is solenoidal. So try to put attention on it. You will get this question of this answer directly if you are getting the concept. It is based basically on this concept, solenoidal vector. Important for MCQ also. So this is how we can attempt the problem based on Gauss divergence theorem. Still, if you are facing any difficulty or doubts that how to find the limits from the region, you can go through from the to the previous lectures where I have done discussion that how to find the limits from the given surface. So thank you very much for watching, and please go through the whole lecture in order to understand the concept related to Gauss divergence theorem. So once again, thank you very